Okay, you ready to get started on this wonderful Friday here? Um, Hope you had a good community day on Wednesday. Maybe you got to volunteer someplace. Um, I've I've done the buckthorn removal a couple years ago. That was really good. It taught me a lot about buckthorn, and so since then I've been doing lots of buckthorn removal on other places, like at my house in Duluth. Um, So there's some nice activities out there. But today is Friday. So usually we do more of a review on Friday, but because we didn't have class on Wednesday, we're going to walk through the discussion kind of virtual pet stuff here. I will point out one thing that we would have done on Wednesday that we didn't under the learning activities, learning material. Towards the end we talk about math uh, class and some math methods here, and I'll just mention them. Um, there are methods to do things like absolute value, raise something to a power, do a square root, and also do random. And to do those, you say math with a capital M dot this. And so you do have access to a bunch of math functions. So sometimes you may see we'll be using those. But again, we're not going to go into much detail on those. Just know they're out there. Also, I think this high-low guessing game example is quite useful, especially if you're working on the assignment here. You start with this high-low guessing game that just picks a random number between 1 and 100, keeps it as a secret number and asks you to guess it. It then checks if your guess is too high or too low, or if you got it right, and then quits. You only get one guess out of 100, so it's not the easiest game to win. So your job is to put in a while loop in here so that it will keep repeating until you get the guess right for that. Um, so that's a nice example and kind of sets you up for the assignments here. And Chris has a nice walkthrough of that on this video here. We talk about it. We do a similar thing in CIS principles with the app inventor block code for this. So, okay, so that's something you might want to look at. Okay, so what are we going to do with the discussion this week? So we're going to try to work on a virtual pet thing. These were a big thing when my kids were young. So this was a long, like well before you were born. There were these little virtual pets. The ones we grew up, my kids grew up with were called Tamagotchi pets. And they were on like a little key ring here, had this little simple graphic, and they just required attention throughout the day. You had to feed them. There were just a couple buttons on them, and one was to feed them, one was to pet them. I forget what the other ones were. And again, you could go through and if you didn't feed them regularly, they ran 24 hours a day. They'd get sick and eventually die for this because of something you didn't do here. I don't know if you may have not have ever had one like this, but maybe you had something online, like in a game or something like that, where it was a virtual pet. Uh, oh no, in some ways it's kind of like a simplified version of The Sims. And again, I'm thinking you're probably too young to have even played The Sims, so that's really sad. So, what? Good. That's good that someone's played The Sims there. Again, where you have this virtual thing. So we're going to try to make a real simplified version of that here. So we're going to start with this code here. If you click on this starting code, it opens this up. Now this is something we're going to have to copy and paste into our project. So I'm going to start with a new project in NetBeans. File, new project, hit next, and give it some name. Unit 5, virtual pet. I'm just going to skip the imports and the package up here and the class. I'm going to go down to the main and just copy from there on because I know from main it should be all the code should be the same. So I'm just going to copy from the public static void main line all the way down here. Copy that. And then over here, again, I'm going to do the same thing, start at public static void main and go all the way down and paste that in there. Um, I'm going to clean up some of these comments so it's a little easier for you to see. I'm going to make this a little bigger here. So when you process in, we didn't get the import. There was an import at the top. So you can either go in and grab that import second, or if you're just here, you can just say add the import because we need the import for the scanner. So once you do that import, it should be all here, and it should run without any errors, assuming you've got all. Sometimes we're mixing some of the too many braces and stuff like that. So as long as you have your braces matching up, you should be able to run this. And here we have a pet dragon. Dragon is awake. What would you like to do? And again, you can feed the dragon. Oh, the dragon goes to sleep. Oh, you feed the dragon, dragon goes to sleep. Your pet dragon is sleeping. What would you like to do? And you can ignore the dragon or whatever. And it just goes forever for this. And it cycles between two states, awake and sleep. And so in each state, you have the one that's awake, you can pet or feed it. And if you pet it, it stays awake. If you feed it, it goes to sleep. When it's asleep, you can ignore it and it stays sleeping, or you can pet it and it wakes up. So that's the basic diagram. We call this a state machine in computing here because there are different states, awake and sleeping, and then there are actions that go from one state to the other. This is pretty common in a lot of like non-player characters in computer games and stuff like that. So if you ever played a computer game and you have some non-player characters out there, they'll have states like patrolling, and they'll just be going back and forth and back and forth. And then as you get close to them, their state will change to observing or attacking or whatever, and their state will change and they'll do a different thing. But depending on what they're doing, they'll be in different states and they'll have different actions here. In the virtual pets, they used to have slightly different views, pictures of the pet. Depending if the pet was sleeping, there'd be little Z's and the eyes would be closed. If the pet was sick, they have a thermometer in its mouth there. So your job is, you don't want to make a pet dragon, obviously. You want to make something different. And so your job is to change this to be your own pet here. So we've got this set up. Your job is to change this into your own type of pet here. And you can change the states from awake to sleep to something else. You can use these states. You can try different actions there. So you want to go in here and look at the code. And so it says, here's the printout at the top. Your pet dragon is just hatched. And then we start a loop. And then we check if the state is awake. We print off the menu. And we ask for the input. And then based on the input, we do something. And we change the pet state. Else, if the pet state is sleeping, we print off a menu. We read in the next state. Depending on the state, we print off something and change the state. And then we keep looping forever. So your job is to go through this. Think of some other pet you want. So I mean, you can do like a realistic pet, your pet hamster, your pet dog, you can make a fanciful, yeah, make an imaginary animal of some sort. So if you want to do your favorite, what is the current, like, we just gave our dog a little beanie baby that we found. there. And so I remember Beanie Babies. What is the current, you don't even know what Beanie Babies are. What are the current stuffed animal trends? Anyone? Well, yeah. Well, you could have a pet version of a virtual version of those there for it. You can do whatever kind of pet you want here. Yeah. So decide that. So go in and start modifying this code to make it into your own type of pet for it. Sound good? So like one thing I want to point out is like you may want to change some variable names here. So we have variables for awake and sleeping here. And if you change like awake, the name here, you've got to change it everywhere. In fact, it highlights it everywhere in your code. So you can kind of see there'd be 1, 2, 3, 4, 5 places, which isn't too bad. But that is a fair amount of places. One thing you can do is you can right click on it. There's something called refactor is to kind of reorganize the code and then rename here. If you do refactor rename and you change the name to something, so maybe I'm going to make this a happy dragon instead of an awake dragon, I can hit refactor and it will change that variable everywhere. Now, it won't change it in the things you print out, and it won't change it in your comments, but it will change it in lots of other places. I mean, every time the variable is used. So a couple of things I'd like you to consider is adding another state there. And you can do that by going into your code here. And we define these states as integers. We have a happy and a sleeping state for this. And so if we want to have another state, we can just define it as a new variable. So let's say I want a integer that is sad here. And I'm just going to give it some other number. I'm just going to keep these in order. This couple of things. We haven't talked too much about constants, but you can make some variables final, which means you can't change them after you set them. And with those, we generally have them all in uppercase to kind of denote that they are fixed. So that's what I'm doing here for this stuff. And then you'd have to add, for the state, you'd have to add a whole new if-then statement for it. Right now we have a sleeping and a happy one. You'd have to add a whole new one for your new state. So if it's in that state, if the pet state is equal to that, you'd want to do something different here. Now, I suggest you create some sort of map of your states like I did. Just grab a piece of paper or something and write this out, or maybe you can have it in your head here. So I'm thinking I have my dragon. If it's happy and I feed it, it gets sleepy. If it's happy and I pet it, it stays happy. If I'm happy and I ignore it, it gets sad. And then one thing we would like is we would like a final state here. So if you could have your pet die if you ignore it for a while, I don't want my dragon to die. So I'm just going to assume my dragon's going to run away if I'm mean to the dragon. So I'll have a runaway state here. So like if it's sad and I ignore it again, I would say it would run away there for that. And I could add that. So again, consider making some sort of final state. And then in your code here, so let's say I had a state final int run away. Then in my loop, I want to change, I have this do loop. Right now, the do loop repeats forever while true. So while true, it just means that it'll do it while that is true, and the word true is always true. So I want to change this to say like while my pet state. And I'm going to write this, I'm going to be repeating. So I don't want to say while the pet state is equal to runaway. I want to say while it's not equal. So as long as the pet hasn't run away, we'll keep looping here. If the pet runs away, we'll quit and you'll end the game. So at some point, it'd be nice to have an end state here where the game ends. Otherwise, the virtual pet is going to go forever. So we consider that. Okay. Sorry, people online, I forgot to switch the screen. So here's the runaway I added here, and here's the while I set up. I changed this from while true to while pet state does not equal runaway. Right now, I don't have any way to get to that state, so I have to modify this to do that. I'm going to modify this sleeping state. Add a sad state. Okay, so I have my dragon. I feed it. I ignore it. I pet it. Oh, I don't have any way to get it sad yet. So if it's happy and I ignore it. So if I check if they pick 3, you ignore the dragon. Okay, let's this again. Ignore the dragon. Ignore the dragon again. Oops. Something's not right there. It is sad and you ignore it. Oh, I was doing not thinking. Okay. There. So what we want you to do is try to do a new pet of some sort or a different kind. I don't know, you can keep trying it if you want. Just I want some different states, some different things, options here. And then you want to put, this is our learning discussion area. So you want to go in there and you want to post it. So you would post your code here for this and do it. Rather than just saying virtual pet, it would be nice if you actually said what it was for this maybe so people can try them out there. So post your code if you want there by sending post your virtual pet code and maybe some sample outputs here. So I would just copy all my code and post that in there and then maybe run it and put a sample of it running here. And then we want to have you post some replies when you try out some other people's code. Copy their code over and then run it and then post your output from their pets as you try to play their pets here. So just add that to the discussion area sometime before Sunday night. Other thing I just want to talk a little bit about is the assignment this week here. So now this week there are 3 options. They're all kind of related to dice games here that you can play. So you can choose one of the dice games. And the first one is see if you can generate a round number between 1 and 10 and print it on the screen. Run the program a few times, see if it's getting random numbers there. And after showing the user the random number, prompt the user to guess if the next random number is going to be higher or lower. Generate the next number, print it to the screen. Run an if then else statement to determine if the user's was correct or not. Tell them the result. So again, we go, we're playing the high-low game. Current number is 3. Make a guess if the next number will be higher or lower, and they guess higher because it's 3 is a low number, the next number is 5, and we say that it's correct. And then we want to add a variable to keep track of how many guesses and a loop so that it will keep looping over and keep guessing. You can count how many times it's going to do that. So that's option 1. Option 2 is what's called knockout dice here. Start by picking a random number between 2 and 12. So this would be like if you're rolling maybe 2 6-sided dice here. And we're going to roll 2 6-sided dice and add up their values and display the dice and the total to the users. So if you're going to do this, you should now 2 dice should be somewhere between 2 or 12. But if you roll dice, you don't get a random distribution between 2 and 12. 2 is much less likely than, let's say, 6 or 7 when you roll 2 dice. Because the number of combinations you can do for some of these, to get 2, the only combination you can get is 1 and 1 on your dice. But to get like 6, you can get a 4 and a 2, or a 3 and a 3, or a 2 and a 4. So there are different combinations that'll add up to 6 there. So that make sure when we want to pick 2 random numbers between 1 and 6 and add them up, because it is a little different than just picking 1 random number between 1 and 12. So if the total equals a knockout value, then end. Otherwise, repeat step 2, roll the dice again, and hit. I believe I've never played craps like at Las Vegas, but I think craps is similar to this. I don't know if anyone knows how to play craps. I certainly don't. Well, I did at one point, but it seemed like you rolled I think you roll the dice, you get the number, and then you roll the dice and you try to get some numbers, or you try not to get the number you roll the first time. It's something like that there. Okay, so again, we generate your knockout number, it's 12. We roll 2 dice and print them out, 4 and 8, and the sum is 8. We roll this out, 9. And again, they keep rolling until they get their knockout dice. So that's the second option. The third option is high roller. Roll 3 6-sided dice and add up the values. Display the dice and the total to the users. Ask the users one by one if they want to re-roll the die. If the user selects a die to re-roll a die, generate a new value and display it. Display the final total of the dice. If the total is greater than 14, the player wins here. If the total is less than 14, repeat steps 1 through 3 until the player finally gets to 14. So, ice rail. 3 6-sided dice is so comfortable to me because I used to play Dungeons and Dragons a fair amount, and I don't know what they are now, but in the old days, that was your attributes were always 3 6-sided dice for creating characters, and there were some rules on this, so I always like this. Okay, so you have to pick one of those options and do it here. Quick note on AI and using stuff not in that we haven't covered in class. One thing is I'm trying to encourage you to make sure the code you're writing is your own. If you can use AI for debugging and that sort of stuff and use AI to help, but I want to make sure you understand the code. So what I run into sometimes is some students will put code in that we haven't covered at all in class here that uses advanced stuff here. For example, in the assignment today, you're beginning to look at all these big things. Our code is getting really long, multiple pages. And what we'll learn eventually is we'll break this code into what are called methods. This will be one method. This will be another method, and it'll break our code into nice chunks. But we are not doing methods yet. Methods are in Unit 7, and we're only in Unit 5. So I don't really want you to do methods yet, but AI is going to want to maybe do methods here. So just be careful of that. If you know how to do advanced features, you can use them. Just tell me that you know you're doing this. Okay, so like Ryder, we were just talking about enums. So enum to me, if I see you doing enums, I would think, oh, Ryder used AI. But if you want to research how to use it, or if you know how to use enums, and a number of you have had some other programming in, before coming to this class, so you might know some stuff. So if you want to use that stuff, just make sure in your reflections you kind of say where you picked up that sort of stuff, so that I don't get, dock you or get mad at you for using stuff we haven't covered in class. So you can just explain when you're doing that. Okay. All right. Okay. So yeah. So keep working. Post your virtual pet to the discussion, the code there, and then work on the assignments. All this stuff is due Sunday night, right?